hear me? Yeah. So my name is Ilja. I'm working for QScience. It's a little startup for innovations in Q sports. And the topic of my talk today is the power of natural language, from ATDD to lean modeling. And at the beginning, I want to make a little survey so I know in which topic you're expert and in which topic I can tell a little bit more. So I ask you questions, and please raise your hand if your answer is positive, and keep it up, because I will ask a related question and I want to see the difference. So that's right, here's the first question. Who knows what test-driven development is? Okay, keep it up. So maybe all. And who actually uses test-driven development? Oh, okay. Who knows what acceptance test-driven development is? Okay. So it's getting lesser and lesser. We actually use acceptance test-driven development. Okay, just 3 arms left. So now you can put it down. And who knows what model-driven software development is? Oh, 3 arms. Who actually uses model software development? 1 arm. So who actually uses model-driven software development with Python? So 1 already. And who knows what lean modeling is? Again, 1 arm, 2 arms. And who actually uses lean modeling? Just 1 arm. This is the guy I'm working with, so maybe I will teach you something today. So let's get started. At the very beginning, this guy here is Constantine the African. He lived in the 12th century and he was a physician and one of the first manual testers. So every morning the people came with him with a flask of urine, and he tested if the people had diabetes or not. And how he did it, he held this flask into the light and checked the transparency, he checked the color, he smells it, and then he tastes it. And if the urine had a sweet taste, the patient had diabetes. So this process is very manual, and it's very error-prone and maybe not correct at all. So what is with software development? So in software development, we have automated unit tests, maybe automated integration tests. But what is with acceptance tests? Acceptance tests validate the software and look if the requirements are fulfilled. So if there is a match between requirement and software. And this process is still very manual, so there is a guy or many guys, maybe the test crowd or the client, would just try the software, and if they are lucky, they will find a mismatch between requirement and software and taste this sweet taste like Constantine the African. And if we find such a mismatch, it will cost us time to fix it, and we will lose money. And if the client finds this mismatch, maybe the whole project will fail. So the main reason for this is not that the developer is untalented or the client is too sophisticated, it's about communication. So this image illustrates the Tower of Babel. It's a short story from the Bible. And so the people wants to build a tower, a very high tower, but reach the sky, and so God is not happy with this, and he sends the confusion of tongues, so he gives everyone a different language, and they cannot communicate with each other, and this tower building fails, this project fails. And it's the same with software development. So, I think some of you know this image. The customer talks in his very business-specific language with his special terms and special vocabulary, and the developer is talking in a more technical way. And sometimes there is a word in the vocabulary of the client which has a different meaning in the vocabulary of the developer. So the developer is thinking, yeah, I got it, but actually he's not. And if you find this mismatch too late, the project will fail. So actually software development is a communication problem. And there is a communication gap between requirements and tests and requirements and implementation. And we need to fix this. So ATDD to the rescue, acceptance test-driven development. And the main idea of acceptance test-driven development is that you specify the requirements together with the client. So maybe during an agile workshop, you sit there and the client tells you what he needs and why he needs this feature, so why it creates business value for him. And the developer is responsible for the how. And this whole process should be very example-driven. So the client tells you real-life examples and real-life situations to explain you his requirement. And these examples are the acceptance criteria for the software. So if our software works with these examples, the software working right, or yeah, mainly. So yeah, as I said, you specify it together with the client, and when you write these examples down in plain text, and this is called scenarios, so requirements as scenarios, and now we want to generate from this natural language files automated tests or runnable executable tests. So how we get from this plain text to a Python test case. And there are many technologies for generating or converting text, natural language text to test cases like Cucumber, Route Framework. And today I will show you a tool called NutSpec. NutSpec can generate code from natural language, and you have no specific no limitations in your sentences. So it's very flexible. It's free for open source projects, and unfortunately it's limited actually to the Eclipse framework and to PyDev. So the people who uses PyCharm, yeah, you can just try it out. So maybe later there will be support for this. And let's dive into an example. It's just a simple shop application we've built for our QScience website. So you have just products, orders, clients, and you can put your products into the cart. And then you have a checkout wizard and check out. So this here is such an acceptance criteria, such an acceptance test in natural language. So we just create a new product. It's a realistic product, so it actually exists. We add it into the cart, and now we make our assertions. So you should be redirected back to the site where we came from, and the total count of the cart items should be 1. The price should match, and the product which is in the cart should be the product we put into the cart. So it should be this QScience scoreboard. And this test is actually executable, not in the slides, but in the software. And how we do this, so let us look to the mapping of this sentence to code. So it's actually just a method, create product. It's very simple. So we just create a product with a title and a price and save it to our database. It's placed into a plain class, has support class. There is no magic. The only magic is this decorator, the text syntax decorator. And the first argument of this decorator is the syntax pattern, the sentence pattern we use. You can use placeholders with prefix with these hashes, and the numbers should match the method signature without self. So you don't want a self in this syntax pattern. And please don't look so scared. You have to specify types, and it's because NatSpec have to know how to make syntax coloring, how to match the sentence, and how to map this to this method. There are dynamic typing, but you have to be very, very carefully how you design your sentences. So if you want to start, just use typing, and if everyone in this room has an idea or proposal how to write this list of strings in a non-Java way, so please come to me and say it to me, because it's very ugly. And I will show you this in a demo. Okay, so just see something. This is our test. I showed you before, and okay, I have just one hand. Yeah, the only line is changed here is this one. So we just assert the status code 302, and we could replace it with this sentence. But yeah, and so let's navigate to this method. It's here. So it's the same I showed you before. And we can look at the generated code from the whole test case. So I will try it with one hand. Yeah, it's this one. So NatSpec just generate method calls. It's really not much magic. And put the arguments you have, you wrote in your sentence at the right places in the method call. So if I change the price here to 200, as I save, the argument here is replaced. So it's very responsive. Yeah. So, and if you run our test suite, so there are, I think, 18 tests here specified as natural language test case. Yeah, they are green, and if we change something, like this one, like I did it before, there will be an error, yeah, failed one. So it is working, and I want to show you some real magic. So what makes natural language sentence special? It's the implicit context. So we don't refer every object in every sentence. So sometimes you just say, he did this, and not say, Ilja Bauer did this, Ilja Bauer did this, and Ilja Bauer put this into the cart. So if we look at this assertion, we see that the method just has one placeholder, the text syntax pattern. But here we specify the response type as second argument. So this magically comes from the method before. So if I put it into the cart, there's the client, and he sent a post request, and this generates a response, and this will be returned, and NatSpec put it into this method call. So this is the cool stuff. Yeah, let's get back. So this one works. Yeah. Okay. So what we've done is we improved our communication. So the ATDD approach tried to help you improving communication with the client. So you have this natural language file. It's a living artifact. So it's a living document. It's not just a Word file, something printed out and full of useless information. you can execute this one, you can execute this requirement, and so your software runs against the test, and so against the acceptance criteria, acceptance test, and against the requirements. So you have a living artifact. You can focus on the important features, so you just build what your requirements say you to build. It's more TDD than ATDD, but yeah, it's a feature. And you can measure your progress by the green acceptance tests. So if you have 10 of 20 green acceptance tests, you're half done, in theory. So this is a kind of tool you can measure your progress with. So we close this gap, or try to close this gap between tests and requirements, and close also a little bit this gap between implementation and requirements, but not really. So why we just generate test code? NetSpec is not limited to test code. NetSpec is very general. Why we don't generate models, forms, wizards, or any other Django artifact or software artifact? So actually, the topic of generating code from specifications is the topic of model-driven software development. It's mainly used in the Java world. So, like you see in our little survey, no one uses it with Python. And I did not find any Python frameworks for this. And the main concept is to put another abstraction upon your code, which is very near to the business model. So you write formal specifications. These are not natural language specifications. There are braces, there is special syntax used. You are very limited, and but you are nearer or closer to the business domain. And so sometimes you can just write a short sentence or short code block and generate 7 classes and 200 lines of code or 500 lines of code. So this is the benefit of this. And you write your software in these formal specifications, domain-specific languages. And this is how it works. This is the classic approach. So you have at the left-hand side, or right-hand side for you, you have this modeling framework, and it's very, very complex stack. So the high complexity is very, very risky, and can cost you a lot of money. So you have to get familiar with this. You have to, you have to use it correctly. So very high complexity, and these frameworks are very rigid. So you are not so flexible. You can change these formal specifications, but the code you are generating is depending on this model framework. And if this model framework does not support this feature, you cannot generate it. You can change this modeling framework, but if it's a commercial one or it's closed source, you cannot do it. Yeah, right? And again, we have this Tower of Babel problem. There are many, many different domain-specific languages. And for every problem, you need a new language. And if you're unlucky, you need a new modeling framework. So you have to get familiar with this too. But the true reason why Python developers don't use this approach and don't use formal specification are the braces. So in each formal specification, there are braces to make the syntax code blocks, and as Python developer, we don't want to use it. So let's get rid of this formal specification and replace it with something else. And we want to use this ATDD benefits we had before, so we replace it just with natural language specifications. And if we replace it with natural language specifications, we don't need this modeling framework. So we just replace it with NetSpec it's a kind of modeling framework, but it's very lightweight. So it's just a mapping between sentence and method. And you're not limited in your sentences. And now you can generate Django code. So I will show you this in a demo too. Yeah. So this one. So this is still this shop application. And let's see, or let us look to this client model. It's defined in a natural language way, so we say every client has a client number, and it's a unique identifier for clients. This is just a comment for documentation. A client has an email, a first name, a last name, and an exclusive billing address and an exclusive shipping address. And this sentence just generates one-to-one fields. So, and if we look at the generated code, it looks like this. So again, just method calls, no magic. And to generate the actual models PY or our actual models, we have to run this because this is just a generator. So the generator is generated, and now he generates the abstract models. So we just run it, and I will delete this models abstract. It's the file is standing here in this code, and just delete it. So you see that actually something is happening if I run it. Yeah, there it is again. And now we can look to our client base, and we have some documentation. It's not nice, but yeah, we can improve this. We have a verbose name for model and for properties, and these are translatable strings. So it's very, very, yeah, I don't like to write this each time, so I just get it generated. And if we don't specify a type for in our natural language specification, the generator just generates the char fields with a max length of 128. So, yeah. This is the first example of lean modeling, but cool feature is, so this one, there is a checkout form, a checkout wizard. And it's very ugly, it has no CSS style sheets, but you can improve this. And I can enter here some stuff. I have to enter here an email. So this one, and here is a checkbox. So if I tick it and press on submit, there will be this billing address, and if I not tick it, there will be then payment options. And all of this stuff is defined in a natural language way. So this is the file it came from. So I just write it in such a way, and I actually can define how these fields are displayed. So I think this is it's a feature everyone needs. So you want the first name, the last name displayed next to each other in the email. Onto the next line, you can specify headings here, and or the sentences are coming just from a test support class I wrote. So if you don't want to use it, fork my test support classes and make your own thing, or you can write it from scratch. So here is this checkbox, this different billing address checkbox. And actually I can use this for step 3 as condition. So yeah, and it generates me this checkout wizard. So just model forms and normal forms. And here's the condition it's generated to. And yeah, I have to subclass this wizard. and have to implement the dot method. So this is not generated, but I think nobody wants to be generated. So yeah, this is my example, and very briefly, because I'm very quick. This is the model, the test support class. So just a plain class with methods, and every method has a syntax pattern, and I just create classes I defined before to hold this information and just put it into a dictionary, and then while I'm generating this, so I don't show you this, there is a NutSpec template file. So this code generation is templated with just, again, a plain class, and this special placeholder here is replaced by the actual code. So very simple, and this also works, so this is how it works for tests and for these generators, but the generators itself uses templates written in Jinja to generate the actual model. It's very ugly because I have problems with this line breaks, so I have to solve it. But it works, you can customize everything. So let's go back to my slides. Okay, so we have all of the benefits of this ATDD approach. So we have readable specifications. They are readable for the client. In this case, in this project, the client, so I were the client and he was the client, so our startup was the client. So we are very technical people, so we understand the more technical specifications. If you want that the client understand this, you have to write this in his business, in his domain-specific language, with his words and his terms and his vocabulary. So the nicest feature, the biggest benefit of generating code is that you can generate from one specification many classes, many artifacts. So we can generate models from this specification I showed you. We can generate it also the REST API, and we can generate as example JavaScript models. So every time I change my model, my natural specification, my Python models are updated, my REST API is updated, and my JavaScript models for a specific framework are updated, so I can use my models in my JavaScript code to validate forms or use the REST API. So, yeah, what's the next steps? Try it out. There is an update side, the software, so the Python support of NutSpec. So it's very pre-alpha. So I'm responsible for this, and if you have errors, yeah, I'm the guy you have to blame. So you can just use this update site. You will get the newest version from the trunk with all the nice features and all the nice bugs. Try this Django lean modeling package, please clone it into the same directory as your project. So NutSpec does not support if it lives anywhere in the Python part. These support classes have to live in your project. It's a limitation now. I will try to fix this or to solve this, but yeah. If you get started, please, at first, try out this Python example project. It's not Django related, it's just plain Python. It's very easy to understand, very easy patterns, no much magic, because this lean modeling thing is very much magic. So try to get familiar with NutSpec and generate some tests, and then you can look at this lean modeling thing. And if you have a question and you need help installing the software, use the software or something else, you can contact me. If you have general questions for NutSpec, you can contact me too, but you can also contact this guy here, Christian. He's one of the developers of the NatSpec core. So if you have license questions or something, please write to him. So now there is time for questions. Yeah, thank you.
Thank you very much, Ilja. If you have any questions, please lay them there.
Thanks very much. In practice, how much education do you find is needed for developers adopting this kind of approach, and also the clients perhaps?
So there are two things. This ATDD approach and generating tests from this natural language files with NatSpec is very simple. So you can dive it into with this example project in maybe 1 hour, 2 hours, and you have to get familiar with this. You have to work out the workflow for you, how you write this code. So you can write this natural specification at first, and then map every sentence, or every sentence pattern to a method, or you write first your test support classes, your methods, and then write your natural specifications. And the other thing is this lean modeling. So it's very it's very experimental. Yeah, you know what I mean. So DevBoost guys use it in 2 or 3 big client projects for Java. I use it in this project for Python, and you have to write this library. So this one, you have to work with it a few hours more, a few days more. So, yeah.
Have you heard about the Lattice? It's a Python tool for basically specification testing. It uses similar approach to what NatSpec does. So you actually have a natural sentence and then you have a decorator. But I'm asking that because it seems to me kind of Java-ish. You have a code that you take and generate code out of it. Why don't you just take the decorator that you have there, parse it in Python, and execute it as Python?
So the main reason for this is it's a Java tool, so NatSpec was written for Java, and I added this Python support, and I think it's designed this way, and I think Lattice, isn't this a part of Cucumber?
I think it is.
So, and haven't you limitations in your sentences?
You just write regular expressions.
Okay, so there are regular expressions, and the guys from DevBoost want to avoid this. So we want to limit this and try to make it as simple as possible.
So on one hand, you're trying to be able to do anything because you have natural language. On the other hand, you're limiting it. Yeah, let's see a reason for that. Yeah. But okay, the main question I was wanting to ask is, once you have your models and forms generated from the specification, then you need to do some code updates in it. It doesn't have to be involved, or when it doesn't involve specification, how do you make it work again with your specification so that your generated code is not overriding the code that you have written?
So at the top of this generated file is a comment. Generated file, please do not change it because it's the generated file. If you want to change something, you have to subclass this. And if you want to change it for all kind of generation, you have to change your test support, and so it changes everywhere. And the benefit against this model software development approach is that changing code and changing this mapping is very simple, and if you use model-driven software development in the spec frameworks, it's not so simple. So you have you can easily change this.
Thank you for the talk. You mentioned earlier in your presentation that one of the problems with all these external tools is that if they don't support what you need, then you are either stuck or you essentially have to write your own DSL. And maybe I misunderstood it, but the way I see it, that essentially here you are writing your own DSL.
Yeah.
So I'm just wondering then, what does it have over like just a generic DSL approach? Because probably it does, but I didn't see that.
So if you write your own DSL as you write it with model-driven software development frameworks, it's more complex. And I think this is very simple. So if you write your own DSL, you have to learn it at first. So this approach is more simpler, just in mapping. And you're just limited on the types you have. So you just can use strings, integers, floats, and lists for the placeholders. But the code you're actually generating is free. And so there are not so many limitations. And if you have limitations with the software, yeah, it's the same problem. But the risk of this is much lower. So how do you write your DSLs?
Well, we don't use DSLs because we found that it's simpler without them, because like whenever we try to expose it to end users, they just put something really complicated that was like horribly not performing. So we just figured that it's better to give them an export, and if they need something, then we just hear the optimized view for them. But yeah, like the other part of the question is that then you use classical testing when testing and your programming is separate. That's a little bit like double entry bookkeeping, so that your tests check your model, and therefore if you have like only a single source of truth, then if you make a mistake there, then that's going to generate into your test and into your code, and everything's going to be real.
Yeah, but if you write your test and your test is wrong, he will validate the wrong thing.
Oh, absolutely.
Yeah, so it's a general problem of testing, I think. So, but maybe through this reuse of patterns, you will not make so many mistakes because you reuse these patterns. If you write your test by hand, you maybe duplicate code, and maybe there is much more errors, and these specifications are you write it with the client. So these are just examples, and if the example is wrong itself, so it's a communication problem again, so the client describes you wrong, and if you map it wrongly, yeah, it's a bug. So you will have to find it. Yeah, so this problem, you have this problem, yeah.
Okay, thank you.
Thank you very much, Ilja.